Hey there, welcome to another session of math problem solving. This is Bharat Divyan from Zubswang Academy. And in today's problem, we have three numbers ABC such that the LCM of the first two, AB, is 1000, the second and third, BC, is 2000, and that of the first and third, which is CA, is 2000. How many sets of numbers ABC, how many ordered sets of number ABC exist? Okay, so this is the question that you need to solve. But instead of trying to solve it all in one single video, I'm going to split this into a couple of different videos. So this will be the first part alone. And the idea here is to just develop an intuition behind LCM. So we'll just focus on getting that intuition first, because without that intuition, you won't be able to solve it. And for those who are brave enough to go and figure out the answer, you're free to pause this video at any point of time and start looking at it. You can do it right away, or you can listen to the part where I've explained the intuition behind the LCM and then see how you can take it forward. Okay, so let's begin. By the way, this is a problem typically for high school students. Somewhere between grade 8 till grade 10 would be an ideal point of time for you to attempt this problem. But that said, LCM is a concept that's introduced in, say, grade 5 or grade 6 in most schools. So if you understand what LCM is, then you can pretty much take it from there. Nevertheless, I'll still explain what it is, and you can always see how you can solve it after you understand this particular video. I mean, just watch this particular video. Okay, let's get started. Now, numbers have multiples. So if I take 2, then I have a series of multiples. So 4, 6, 8, 10. These are all considered multiples of 2, because by repeatedly adding 2 again and again, I can end up at any of these numbers. So 2 added twice is 4, 2 added 3 times is 6, 2 added 4 times is 8, and 2 added 5 times is 10. In other words, if I multiply 2 with any other number, I should be able to achieve one of these numbers. So this is what I would call a multiple of 2, and 11 is not a multiple of 2. Because no matter what I do, if I multiply 2 with an integer, I would never be able to reach 11. So 11 is not a multiple, and 10 is a multiple. Similarly, if I were to take 5, I would say 5 has a multiple of 5 itself, because I can multiply it with 1, 10, 15, 20, so on and so forth. So even for 5, 11 is not a multiple, because I will not be able to multiply 5 by an integer. In other words, I cannot add any number of 5s together to reach 11. Because if I add 2 5s, I get to 10, and 3 5s, I get to 15, but I'll skip 11 altogether. So 11 is not a multiple. But while I write down these multiples, especially with 2 and 5, I realize something common. And remember, intelligence is nothing but knowing the difference between similarities and similarities between differences. So there is something similar between the two, which is the value 10. 10 is a common multiple between 2 and 5. Not only would 10 be a multiple, even 20 would be a common multiple between 2 and 5. Even 100 would be a common multiple between 2 and 5. Even 1000 would be a common multiple between 2 and 5. And if you can keep going, you will realize that pretty much 1 billion is also going to be a multiple of both 2 and 5. And that's the reason we are interested not in how large a multiple we can find, but rather the smallest multiple that we can find, because once you get that, the rest of it becomes very easy. And in this case, the smallest multiple in both 2 and 5 is 10. And this is something that we call as the lowest common multiple, or LCM in short. So LCM basically means what is that multiple for two numbers which is common to both of them, right? And in that, it should also be the smallest such common multiple. Okay, now that we understand LCM, we can pretty much apply this to any two numbers. So if I were to give you, for example, 11 and 10, right? So I can go with 11's multiple, I can go with 10 multiple, and eventually you'll realize that 110 is going to be the LCM, right? So 11 times 10 is 110, and 10 times 11 is 110. Now, if you notice this, there's something interesting here. The LCM 10 is nothing but the product of the numbers, 2 times 5. And the LCM here, 110, is nothing but the product of the numbers, 10 and 11. Let's make a small change. What about the LCM of 10 and 25? So 10, as you can see, the multiples are going to be 20, 30, 40, and 50. And for 25, the multiples are going to be 25, 50, 75, 100. Now you already see something common, which is 50. Okay, however, the product of the two numbers, 10 and 25, is 250. And it's not 50. So you couldn't blindly just say, hey, okay, I just need to multiply the numbers and I'll get the LCM. That's not true. It's true only in a specific case. One of the reasons for this is to understand what makes the numbers themselves. Right? Can we break down the numbers further? For example, 10 is nothing but 2 times 5, and 25 is nothing but 5 times 5. And if you see this, there's a common factor that they both have. This common factor is called the highest common factor, HCF. Right? So the HCF, or greatest common divisor, GCD, is 5. So if you take the product of the numbers and divide it by the HCF, then you would get the LCM. Okay, so that's something that you can think about. So if I have two numbers, A and B, if I multiply them, that is nothing but the product of those two numbers, HCF and LCM. Okay, now why is this so? What is the intuition behind it? This is a relationship that we see. So in case of 11 and 10, the HCF is 1, the LCM is 110, and A is 10 and B is 11, and we end up getting this value. Similarly, for 2 and 5, it's 2 times 5, that's the two numbers, and the HCF is 1, and the product, the LCM, is 10, which totally works. Okay, and same with 10 and 25. So you have 10 and 25, which is 250, which is nothing but 5 being the HCF times the LCM, which is going to be 50. Okay, so there you go. So this is one bit of how LCM, HCF, and the product of the numbers are related. But if you see something that's common, it's the prime factors. If you look at the numbers, there's something about prime factors that comes into picture. So let's take 10 and 25 again. Right, so 10 and 25 is made up of 2 times 5, and 25 is made up of 5 times 5. Okay, so in other words, I could write it as 2 power 1 times 5 power 1, and 25 can be written as 5 squared. Now, in order to find the LCM, you need to find the maximum power of, so even this can be written as 2 to the power 0 times 2 to the power 0 being 1. So the LCM is going to have every single prime factor that's there in the numbers. So for example, the LCM of 10 and 25 is going to be, it's definitely going to have a multiple of 2 and a multiple of 5. Okay, for that, to find out which power of 2 is going to be there, look at the maximum of this. Maximum of 0 and 1 is 1, and the maximum of 1 and 2 is 2. So in other words, it's 2 times 25, therefore it's 50. Okay, so let's take another example. Let's take 16 and 24. Okay, 16 and 24. So 16, as you can imagine, is 2 to the power 4, and 24 is 3 into 2 to the power 3. 3 power 1, in other words. So since there is a 3 here, you can fill this up as 3 power 0. So you know for a fact that the LCM of these two numbers is going to have 2, a multiple of 2, and a multiple of 3. But which power of 2 is going to be there? I mean, not a multiple, an exponent of 2, a power of 2, and a power of 3. And for that, you need to fill in the maximum value, that's 2 power 4. and the maximum of the powers between 0 and 3, which is 1. So in other words, it's nothing but 16 times 3. In other words, it's 48. Right? So this is the key to figuring out LCM. So to find the lowest common multiple, you need to look at the comprising prime factors and look at the power that they have. And that is what helps you determine this. So now let's come to our problem. We want to find out two numbers AB such that their LCM is 1000. And if the LCM is 1000, prime factor is 1000, and you realize it's 2 cubed times 5 cubed. So A and B should have factors of 2 and 5. So A can be considered to be 2 to the power of x1 and 5 to the power of y1, and B can be considered 2 to the power x2 and 5 to the power y2. Right? And together they are going to form 2 cubed times 5 cubed. So you can conclude from this, the intuition here is that the maximum value between x1 and x2, should be 3. And the maximum between y1 and y2 should also be 3. So it's possible that y2 is 3 and y1 is 0. Totally fine. It's possible that x1 is 3 and x2 is also 3. That's also possible. So you can see that there's a set of combinations for x1, x2, y1, and y2 that would allow for this to work out. Okay, so if you can follow this and understand the intuition behind LCM, that's the first step towards solving this problem. So I'm going to stop this video here. Let's consider this part 1. We'll be coming up with part 2 very soon, but if you'd like to see more about this, please do leave some comments so that I know you're watching the video, and let us know what you think about it. And if you like the video, please do like, share, and subscribe, and I'll see you in the next video. Thank you so much.